Hello students, welcome back to Organic Chem Wars YouTube channel. In this video, I am going to teach you how to solve the given question. This is a JEE advanced level question, so let's analyze the question carefully and find the right answer from the given options. What is the molecule given here? It is a molecule with two functional groups. One is ketone, the other one is ether, and also we have a cyclopropane here. When it is treated with water in presence of acidic medium, what will be the product? So it's basically acidic hydrolysis. You can also observe here the oxygen given is oxygen 18, that is a labeled oxygen. Why we are using isotopic oxygen here? Because it will help us to know what will be the mechanism of the reaction and what will be the final product. First, let me explain this question and the mechanism answer in detail, and in the end I'll tell you how to solve this question under 1 or 2 minutes. Now, whenever we have ether and ketone, when it is treated with acid, oxygen from the ether functional group is the one which will get protonated first. The lone pair present on the oxygen will attack the proton, right? The cyclopropane group will remain as it is, so is the ketone. Now, what will be the charge on oxygen now? Oxygen will be plus charge. Once it gets protonated, we have labeled water, that is labeled oxygen here. It should attack the molecule now. Whenever we have ether, it can either undergo SN1 or SN2 mechanism hydrolysis. We know that cyclopropane cannot form a carbocation because it's highly unstable, right? And also this carbon, it cannot form a stable primary carbocation. So SN1 is not possible here. SN2 will take place. That means what? The oxygen will attack the molecule and this oxygen carbon bond will break. So it is happening in one step. Therefore, how do we write this? We are going to write it like this. This is butanol molecule, and what do we have here? The oxygen is attacking the cyclopropane here, right? So we'll write down this as it is, right? Since oxygen is trivalent here, I'm going to write a plus charge over here, and the ketone is as it is. Look at this butanol in the options. We don't have it. That means what? This is just a byproduct. We need to identify what happens to this reactant, right? Now, the first thing is the oxygen will take back its electron. That means we are regenerating the catalyst. So the H plus will be regenerated. And what happens to this? I'm going to write here. Look at this. This is a cyclopropane molecule with OH group like this. And we have a carbonyl here. Students, remember the cyclopropane molecule is not so stable due to the ring strain in the molecule, because the carbons here are sp3 hybridized. Whenever it is sp3 hybridized, we know that the bond angle is 109.5 degree. But in cyclopropane, here it is 60 degrees. So there is a bond angle deviation. There is a strain in the molecule. That's why if there is a possibility, always this ring will break open, right? That is one reason. The second reason is due to this carbonyl. So what I am trying to explain to you is that when this oxygen takes away the bonding electrons from here, look at this carbon, right? So it already has one hydrogen here. So 1, 2, 3, 4. There are 4 bonds. Once these electron goes here, this carbon will become pentavalent, which is not possible. So immediately it has to break open the bond, where it will break either here or here. But it prefers to break open here. Why so? Because these electrons will shift here, so that these pi electrons will shift to oxygen. Why this is happening? Because look at this, when the electron goes here, I'm going to write a double bond, right? Now there is already a hydrogen here. I'm going to write that as it is. Okay, so it goes here, the hydrogen is here. Now this bond is already broken, no bond. So this is attached to what? CH2, right? And this CH2 in turn, it is attached to CH, right? And double bond carbon here. And what about this oxygen? It is taking away the electron O minus, and CH2 CH3 is as it is, right? I'm writing the carbons, hydrogen, oxygen here so that you will understand how the mechanism is taking place, right? So now CH2 CH3 is as it is. Now whatever the proton was earlier, it was given away. So look at this. Once these electron comes here, it will take back that particular proton. So what do we have here? This is the oxygen. So that means what? I'm going to write it as COH. That's a aldehyde basically, right? Then it will become CH2. And what about this? This also will become CH2 by abstracting the proton from here. And then we have CO, CH2, CH3. I'll write this as it is. Now, what did we miss out here? Look at this. When this oxygen attacks here, this is our labeled oxygen. This is our labeled oxygen. So you can mark that again, right? So this aldehyde oxygen is the one which is labeled. So where do we have a molecule with aldehyde and ketone? Let's check that. We have an aldehyde and ketone. What about here? The cyclopropane is as it is, not possible. We have an ester, not possible. Ester and acid, not possible. Therefore the right option is option A. Let's give the UPAC name also. See here, we have an aldehyde and ketone. Aldehyde gets the higher priority. So 1, 2, 3, 4, 5, 6. At 4th position, we have a keto, or you can call it oxo. 4 oxo and 6 carbons. So hexanal. So let's verify for this. 1, 2, 3, 4, 5, 6. Yeah, 4 oxo hexanal. Therefore the right option is option A. So what did we do? First we attacked the proton on oxygen. Then there has to be a SN2 attack of water. It attacks the cyclopropane, and then the labeled oxygen stays with this molecule, right? And then the ring will open. What are the two driving force I told you? The cyclopropane will have a ring strain. That is one thing. The second thing is that it is attached to carbonyl. So when the electrons will go here, it will be stabilized by the carbonyl. That is the driving force. And then finally it should get back its proton. So then we are going to get a 4-oxohexanal molecule as it's given in option A. Therefore the right option is A. Now students, if you want to solve this under 1 or 2 minutes, then how to do this? The best way to do is eliminate the other options. When you have a cyclopropane, most of the time if you have a open ring structures, they are the one might have a right answer. So you can easily eliminate option B. Now, the second approach, ester formation. Why would we get an ester when we have ether and water? Not possible, right? Then the third one, the labeled oxygen is given. That means it has to react with our molecule. And you see in option B, C, D, there is no labeled oxygen. That means it has to be option A. These are the 3 ways. And if you're still not sure, you can do the series of reactions quickly and check what might be the answer. So by that way, you can solve this question under 1 minute. So this is how you have to solve a difficult question step by step or quickly. So I hope you have understood this, and if you still have question, you can always post them under the comment section. Thank you for watching this video. Until next time.